All right. So yesterday we talked about similar shapes. I need you to stop talking, please. Yesterday we talked about similar shapes. So we looked at 3D shapes and 2D shapes, and we had to know if things move. If things were similar, if two shapes were similar, either 2D or 3D, then what did they have to have? Same angles and same ratio of sides, okay? So when we specifically look at triangles, I know we used a triangle as an example yesterday. When we specifically look at triangles, there are some rules we can use so that we don't actually have to check all the sides and all the angles. We can just check three things and we know that triangles are similar. And these are the rules you guys have seen before. Can we just shut those blinds so that you can see the screen properly? You guys all right with that? Yeah? All right, so you guys in the past have probably learnt rules for congruent triangles, which means they're triangles which are exactly the same, okay? We're looking at similar triangles, so the ones which have been enlarged or dilated. So this is about still that ratio side of things, okay? So there are three rules we need to know for similar triangles, okay? So this time we just need to prove three things instead of proving every side and every angle like we did yesterday, all right? So the first rule is called side, side, side. Side, side, side. Okay, or sometimes we just write S, S, S. Okay, so side, side, side. What do you think that might mean when we're talking about two different triangles? The three sides are, it's not about the same because it's similar, in the same ratio. Okay, so the corresponding sides, the corresponding lengths of all three sides are in the same ratio. Which means the triangles are similar. So instead of having to check all the angles, you know how yesterday we had to check all the sides and all the angles, and it had to be that all the sides are in the same ratio and all the angles were the same? Instead of having to do that with triangles, we just have to check all three sides. And we can go, yes, tick, they are similar. So for example, if we look at triangle ABC, and DEF, we've got these triangles. We still need to prove it with the three sides. So what do you think is the first thing we need to do? We need to work out the ratios, and we need to know which are the corresponding angles or corresponding sides. So this A here, where's the corresponding point on the other triangle? F. Okay, so you've got to realise that sometimes they can be mirror images or they can be turned around, rotated. Okay, so you need to be able to work out which ones. And if you do the highlighting first, it will make it a lot easier. So B corresponds to E, and therefore C corresponds to D. And if you do that, things get a lot easier when you're writing things down. So because of that, we can look at this and we can say, okay, the ratio of A to B and yellow to blue again, so F to E, is equal to 3 to 6, which is the same as saying 1 to 2. Okay, so that length to that length is the same when we simplified it to 1 to 2. B to C and E to D. You'll notice the colours make it way easier when you're doing this. So blue to green and blue to green is 5 to 10, which is the same as saying 1 to 2. It's the same ratio. And then our last one, C to A. So green to yellow, which is D to F, is 7 to 14, which is the same as saying 1 to 2. Can everybody see where we got to there? All right, so now because all three sides are in the same ratio, we can now say triangle ABC is similar to triangle yellow, blue, green, so F, E, D. And now the reason for that is because we haven't checked every side and every angle, we need to actually say why. And so we need to say side, side, side. Because all three sides are in the same ratio, that's how we know. Yes. Yes. Thank you very much. Therefore, triangle ABC, similar to triangle FED, because all three sides are in the same ratio. So we don't have to know all the angles for these triangles to know that they are similar. But remember that in other shapes, 2D shapes, 3D shapes, other than triangles, you would need to check every side and every angle. It's just for triangles that these rules work. Any questions about that? All right, the next one is angle, angle, angle. So there's three rules we're going to look at today. Side, 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 angle, angle, angle. What do you think the rule is for this? What do you think the rule is? Good, okay. All corresponding angles. Angles are the same. Therefore, the triangles are similar. For example, now I know this is actually, so where are the corresponding angles here? P and A, Q and C, and R and B. So how do I say that they're the same? So angle QPR, remembering that if we're writing an angle, if we're writing it in this way, you need to make sure that the angle is in the middle. So it's going where you make the angle from. So the angle between QP and R. So it's where the angle is at P is equal to angle CAB. So again, we have to put them in the same order, just where the colours make sense, okay? Angle, we'll keep going with the same style. So let's go with angle RQP is equal to green, blue, yellow, so BCA. And then angle PRQ is equal to angle yellow, green, blue, so ABC. So each of the angles are the same. So therefore, what can I say? And we need to write A in brackets to say because all the angles are the same. Because we haven't checked the sides, but because all the angles are the same, we know for triangles that these are similar. Everyone good? All right, the last one is not that hard, but you do need to know that it has to be in the order it's writing. So the last one is side, angle, side, and it has to be the side with the angle in between the other side. I'll explain what that means in a second. So side, angle, side. So it must be two sides and the angle in between. It can't be any angle. It has to be the angle in between the two sides, you know. So that's important. So two sides must be two corresponding. Hang on. Must be in the same ratio. With the angle in between being the same in both triangles. So if that happens, we know that the triangles are similar. Yeah.
Do we not do the angle side RHS?
No, so that only works for congruent triangles. This works for similar triangles. All right, so for example, which we're on. Now, I've given you extra information in this one than what you actually need. But they will often do that as well because they want you to actually be able to work out which one should be where. All right, so which angle corresponds with B? M. Which angle corresponds with A? Sorry, guys, could you just change that 50 to a 70? Because it will not be 50. Oh. Doesn't actually really matter to the whole story, but I would rather it be a bit more accurate. And it's still not accurate with the 10 there either, but anyway, doesn't matter. Why would it be Q? So if we're looking at the A, so therefore, what's it more likely to be? It's more likely to be N. So therefore, C is with Q. Now, if you knew that A was 70 and you definitely knew that A was 70, then could you use that angle as in this rule? No, okay, because you have to know the angle in between the two sides we know. So we have to use angle B and M for this to work. Otherwise, we have to double check every angle and every side. Okay, so it's really important that you know that it has to be side, angle, side. Okay, the angle in between. So if we look at this, we're going to say angle B, so angle ABC is equal to angle N. Thank you very much. Okay, is equal to angle NMQ. Then we're going to look at side length AB in ratio to, so blue, yellow, so NM equals 9 to 3, which is the same as saying 3 to 1. And B to C, yellow to green, so M to Q is equal to 12 to 4, which is the same as saying 3 to 1. So because two of those sides are in the same ratio and the angle in between them is the same, we can therefore say that they are similar, okay? So therefore, triangle ABC is similar to triangle blue, yellow, green, NMQ because side, angle, side. If you get stuck with these rules, you can always just try and check every angle and every side, but sometimes you don't get given that information. Okay, so side, 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 angle, 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 they're pretty easy. So the one you really have to just remember is side, angle, side. Any questions? You okay with that? Okay, you need to do exercise 10D, questions 1 to 10, and we have finished this chapter. Next lesson, you're going to need book 2. We've actually, other than finance, we've finished with this book so after the exams, you'll need this book back when we do finance. But we'll need book 2 for the next little bit. Okay? But for today, exercise 10D, questions 1 to 10, I reckon you should be able to get them finished.